Hello dear learners. In this video session, we are going to learn about transpose of matrix. Objectives of this video session are: students will be able to determine transpose of matrix, solve the problems based on the concept. Look at the orientation of few objects. Let me take my bangle. If I'll just take this bangle, I'll rotate it. Is its orientation changing? No. Now let me take this diary. I'll change its orientation like this. Now its orientation is affecting. So let me take one more example. Transpose of matrix. A matrix obtained by interchanging rows and columns of a matrix is called transpose of matrix. It is denoted by A dash or A transpose. If A is matrix Aij with order m by n, then its transpose will be the matrix Aji and its order gets reversed by n by m. For example, let me take A as a row matrix 1, 2, 3. Its order is 1 by 3. So, if I will take its transpose, it becomes a column matrix and its order gets reversed. It becomes 3 by 1. So, let me take one more matrix, B matrix. It is a square matrix. It has 2 rows and 2 columns. So, when you take its transpose, its order is not going to be affected, but still you have done its transpose by making its first row as its first column, its second row as its second column. So, let us study few properties of transpose of matrix. Property number 1, for any matrix A, we have transpose of matrix is matrix back. For example, let me take A as this matrix, let us take its transpose. So, row 1, 2, 3 has become column number 1, 1, 2, 3. Row 2, which is consisting of elements 4, 5, 6 becomes column 2 consisting of the same elements 4, 5, 6. Now, let us take transpose of this A transpose again. So, you are getting 1, 2, 3, 4, 5, 6 as 2 rows and you are getting this matrix A back. Fine. So, this property is holding that A transposes matrix A. Property number 2, for any matrix A of any order and a scalar K, we have this property verified. K A transpose is equal to K into A transpose. So, let us take one example. A is a matrix 1, 2, 3, 4, 5, 6 and K is a scalar quantity 2. So, 2A, that means you are going to multiply each and every element of matrix A with 2. So, this becomes 2A. You take its transpose. So, rows and columns are going to interchange and you are getting this matrix. A transpose, take transpose of this matrix A, multiply this by 2. So, you are getting 2A transpose. So, this matrix and this matrix, both the matrix are equal. So, this property is also verified that Ka whole transpose is equal to K into A transpose. Property number 3, for any two matrices A and B of the suitable orders, that means they are going to be of the same order, this property is satisfied. A plus B whole transpose is equal to A transpose plus B transpose. For example, this is matrix A, this is matrix B. So, first step is to check out their orders. This order is 1 by 2 and B matrix is also having order 1 by 2. So, you add both the matrices A plus B. You remember that we can add corresponding elements 1 and 3, you are getting 4. 2 plus 4, you are getting 6. Then you take LHS of this property A plus B whole transpose. So, this matrix 4, 6 can be written like this in the transpose form. Then you take RHS, take A transpose, take transpose of this matrix A like this. B transpose, take transpose of this matrix B like this, add these together and you are getting 4, 6 column matrix back. So, LHS is equal to RHS, you can say that A plus B whole transpose is equal to A transpose plus B transpose. Next property, for any two matrices A and B, we have A into B whole transpose is equal to B transpose A transpose. This is also called law of reversal. Because we have reversed the order B A, A B, the order has been reversed. So, let me take one example. So, let A is a matrix consisting of 2 elements 1 and 2, B is another matrix consisting of elements 3 and 4. You multiply A, B, you can check out that order of matrix A is 1 by 2 and order of matrix B is 2 by 1. That means AB is going to be 1 by 1 matrix. So, 1 will be multiplied by 3 plus 2 will be multiplied by 4 and your final answer is 11, but that element 11 is to be written in the matrix notation. After that you take A transpose, 1 2 will become column matrix now. Take B transpose, that column matrix B will become row matrix now. Then B transpose A transpose, you multiply B transpose with A transpose. So, it is going to be matrix 11 back, which is of order 1 by 1. So, you can prove that AB whole transpose is equal to B transpose multiplied by A transpose. Let us solve few questions of NCERT. This is question number 3 part 1, exercise 3.3 of NCERT. The question is, you are given A transpose. Mind it, this is A transpose, not A. You are given matrix B and you are supposed to verify this property. So, how will you start? So, let me first get the matrix A. How can we do so? We have already learned one property, that transpose of matrix is going to give me matrix A. That means I am going to take transpose of this matrix. For that, this R1 3 4 will be made as column 3 4. The next row will become next column and the last row will become the last column. After that, you are already having B matrix with you. So, you are going to add them up, A plus B. You remember how we are going to add two matrices? We add corresponding elements, like 3 will be added with minus 1. So, it is giving you 2, minus 1 plus 2 will give you 1, 0 plus 1, 1, 4 plus 1, 5, 2 plus 2 will give you 4, then last 1 plus 3 will give you 4. So, this is our matrix A plus B. After that, we are supposed to take its transpose A plus B whole transpose. That means, you have to make this like this 2, 1, 1, 5, 4, 4. So, let us solve RHS now. Now, I will solve this RHS. For that, I require A transpose, which is already given to me, 3, 4, minus 1, 2, 0, 1. Then I am given B. So, I can easily calculate its transpose, B transpose like this, minus 1, 2, 1, R1 will become column 1, then 1, 2, 3, that R2 will become column 2. After that, you will add these two matrices, A transpose plus B transpose. This is our right hand side. So, you add them together again by adding corresponding elements, 3 minus 1, 4 plus 1, minus 1 plus 2, 0 plus 1, then it comes 2 plus 2, 4, 1 plus 3, 4. So, you can verify that RHS is equal to LHS, hence this property is verified. Let us move to next question. In this question, we are given A transpose and B, and you are supposed to evaluate this matrix A plus 2B whole transpose. So, again this question is also similar to previous question, in the sense we are given A transpose and we can obtain this matrix A by taking its transpose. So, its transpose, it is a square matrix, so order is not going to be changed, but rows and columns are going to be interchanged. like this. Then I need matrix 2B. That means each and every element of matrix B will be multiplied by 2. So, it is giving you this matrix 2B. After that, you need to add these two matrices A plus 2B, minus 2, minus 4, 1 plus 0, 1, 3 plus 2, 5, 2 plus 4, 6. Then A plus 2B whole transpose. That means this R1 will become column 1 and this R2 will become column 2. So, A plus 2B transpose is this matrix. So, let us move to the next question, question number 5 part 1, which I am supposed to verify AB whole transpose is equal to B transpose A transpose. You can remember that we have named this property as law of reversal. So, in this you are supposed to multiply all the matrices. So, very first matrix is A, B. That means you need to multiply this column matrix with this row matrix. So, how will you do that? Write down both the matrix adjacent to each other so that no calculation error is happening. You can check their orders to be more comfortable. This is having 3 rows and 1 column and this is having 1 column but 3 rows. 1 row and 3 columns. So, after multiplication you will get a matrix of order 3 by 3. So, how will you obtain that? 1 will be multiplied by minus 1, 1 will be multiplied by 2, 1 will be multiplied by 1, minus 4 into minus 1, minus 4 into 2, minus 4 into minus 1. Then 3 will be multiplied by minus 1, 3 will be multiplied by 6, 3 will be multiplied by 1, right. So, this is our matrix AB. After that, for LHS, I need transpose of this matrix AB. So, let me just take its transpose by converting its rows into columns like this. You must have become familiar with this process by now. So, now you require B transpose A transpose. So, I will just write them directly. B transpose A transpose. So, B transpose is column matrix minus 1, 2, 1. A transpose is a row matrix consisting of single row 1, minus 4, 3. When you multiply them, minus 1 into minus 1, you are going to get this matrix. You can see that AB transpose is equal to B transpose A transpose. So, you can conclude at the end that AB whole transpose is equal to B transpose A transpose, fine. So, let us move to the next question. So, you are given this matrix A and you are supposed to verify A transpose into A is I. You can recall I. What is I? I is an identity matrix of the same order. So, let me write A transpose into A. So, A transpose will become this matrix cos alpha, sin alpha, minus sin alpha and last element is cos alpha. After that, you are supposed to write matrix A. So, you have written this as it is. Then start multiplying both the matrices. This is cos alpha into cos alpha. this is cos square alpha, minus sin alpha into minus sin alpha is making it plus sin square alpha. The next element cos alpha into sin alpha, minus sin alpha into cos alpha, let us write next element sin alpha is multiplied by cos, then minus cos alpha sin alpha, last element it is giving me sin square alpha plus cos square alpha, right. So, let us just simplify them. Can you recall this identity? This identity I have done in class 10. So, this is 1. Cos alpha sin alpha and minus sin alpha cos alpha are cancelling each other, it is giving you 0. Similarly, this term is also becoming 0 and that is again the same identity. So, it is equal to 1, which is giving you identity matrix of order 2. So, A transpose multiplied by A is giving you identity matrix for this particular matrix A. This may or may not be holding for every matrix. Let us move on to the next question. What will be value of alpha if A plus A transpose is identity matrix where A is given to you? So, you are given A, write down this matrix A, add it up with its transpose. That means you can write like this. Equate it with identity matrix, which is 1, 0, 0, 1. After that, simplify this further. So, cos alpha plus cos alpha, 2 cos alpha minus sin alpha plus sin alpha is 0, sin alpha minus sin alpha is 0 again, and cos alpha plus cos alpha is giving you twice cos alpha. So, you can see that this is resembling, the zeros are resembling at the same places, the corresponding elements are same. That means you can infer that 2 cos alpha is equal to 1. But the question does not end here because you are supposed to find the value of alpha, the angle. That means cos alpha is half. So, can you think of value of alpha now? If cos alpha is giving me half, what will be value of alpha? Cos alpha is half, that means alpha is 60 degree, or you can say it is pi by 3. So, let us move on to the next question. Now, you are supposed to find out the values of x, y, z, the unknowns, if you are given A transpose A is equal to identity matrix. This question is from miscellaneous exercise of NCERT. So, you have to multiply these two matrices of third order. So, I am writing transpose of A here 0, 2y, z. Our process is same. R1 has been made column 1. After that, R2 will be written as column 2. Then R3, that means row 3 will be written as column 3. Then write matrix A 0, 2y, z, x, y minus z, x minus y, z, that is equal to identity matrix of the same order. That means 1, 0, 0, 0, 1, 0, 0, 0, 1. After that, you can multiply these two matrices. 0 will be multiplied by 0 plus x into x plus x into x. So, which is giving us 2x square. Then 0 into 2y plus x into y minus x into y is giving you 0. 0 into z minus xz plus xz is giving you 0. The next term 2y into 0 xy minus xy is 0. 2y into 2y is 4y square, y into y plus y square and plus y square more. So, you can write next element like this. Then comes last element of this row 2yz minus yz, this is giving me 0. Z into 0 minus zx plus zx is giving me 0. Z into 2y minus zy is giving me 0. Last element is z square plus z square plus z square, which is basically 3z square. Equate it to identity matrix of the same order. Then you can equate the terms, the corresponding elements, which is giving you 2x square as 1. This is actually 6y square. So, this is giving us 6y square as 1. Last term is 3z square, which is also equal to 1. So, all these terms are giving you, like here x square is equal to 1 by 2. So, x will become plus minus 1 upon root 2. Similarly, you can calculate y plus minus 1 by root 6, and lastly you can calculate value of z as plus minus 1 upon root 3. Fine. Let us summarize the topic. A matrix obtained by interchanging rows and columns of a matrix is called its transpose. Transpose of a matrix is denoted by A dash or A T. If A is a matrix consisting of elements A, I, J with order m by n, then A transpose is another matrix consisting of elements A, J, I with order n by m. For any matrix A, you can say that transpose of A transpose is equal to matrix A. For any matrix A and the scalar quantity K, Ka whole transpose is equal to K multiplied by A transpose. For any matrices A and B of suitable orders, we can have A plus B whole transpose is equal to A transpose plus B transpose. For any matrices A and B of suitable orders, we have AB whole transpose is equal to B transpose A transpose, the law of reversal. Okay, with this we just end this video session. So, we will study more properties of transpose of matrix in the next video session. Thank you everyone.